So today's lecture is about the data link layer. As we said, data link layer is the second layer in the TCP/IP protocol suite. So in data link layer uh, the communication is node to node. So if we have a data unit that we want to send from this node to this node, for example, it must pass through many other network devices or routers. So here's a path, for example. So it passes through many of these networks to reach to the destination. These LANs and WANs are connected by routers. So each network you have to connect it to another network, as we will see later, using devices we call routers. The two end devices, hosts, this one and this one, we call them nodes. And these routers also, they are also called nodes. The networks in between the nodes are links. So this is a link, this is a link, and so we have nodes and we have links. You see, here is a link, here is another link between, and here is another link. Here is, so we have in a data link layer, we have nodes and links. The services that data link layer provide, these are the data link layer receives services, of course, from the physical layer, of course, because it's below. If you, this is the physical and this is the data link, so it receives services from the physical layer and provides services to network layer. The duty scope of data link layer, as we said before, is node to node delivery. So node to node delivery. This is a node, this is, so node to node, not end to end delivery. It's node to node delivery. The data link layer of the sending node encapsulates, as we studied before. We said data, when you have data from network, because it receives you see here, if you have you are sending data, you have data from network layer, you encapsulate this datagram from the network layer, because you, when you send, you go this way. So we call that data here datagram. We encapsulate it into a network frame. Encapsulate means what? Adding headers. So we add headers to this network datagram in the data link layer. Okay, so this frame from the network layer is encapsulated into this datagram from the network layer is encapsulated into a frame. The data link layer of the receiving node needs to decapsulate. So when you go to the other side, you have to decapsulate to remove the headers, and then if you want to send it again, you have to encapsulate it again. The services provided by data link layer include framing. So as we said, the data link layer at each node needs to encapsulate the datagram in a frame. Encapsulate means what? Adding headers. So this datagram is from network layer. So we add headers, data link layers headers, to make it a frame. So we call this a frame. uh, network data link layer frame, and this is coming from the network layer. So we encapsulate it by adding the data link layer headers, and we call the resultant data a frame. The node also needs to decapsulate, so this is the services of data link layer. So when you send, you encapsulate, add these headers. But when you receive, on the other side, you have to remove the headers, decapsulate the datagram from, so you receive from the lower layer, the physical layer, for example, or the you remove the headers and send it to the upper layer, because the upper layer does not need this header of the data link layer. It cannot deal with this header. It has its own network layer header, this data. So the network layer will deal with the other header, not this header. So the data link layer will remove this header, which means decapsulated. A frame may have both a header and trailer. So we are talking mostly about headers, but some frames will also have trailers. So the header is at the beginning and the trailer is at the end. The other service is flow control. So flow control means what? You have to manage how much data you send and how much data you receive. You control the rate of that. We have this famous problem when we talk about flow control. It's called the producer-consumer problem. It's simple. If the rate of produced frames is higher than the rate of consumed frames, that means frames at the receiving end need to be buffered while waiting for to be consumed, because you cannot process these frames, all these frames, because the rate is higher than the rate that you can process them. Then you have to buffer this frame until you have time to process them. Due to limited buffer size at the receiving side, buffer means what? Means memory. So if you have, for example, a mobile device, you have limited memory buffer size, and then you have either the receiving data link layer drops the frames if its buffer is full. So if your buffer is full and the consumer is producing frames at a rate that you cannot process, then you need to buffer them. But if your buffer is full, then you need to either drop some frames, or the receiving data link layer sends a feedback. This is the other strategy. So you send a feedback to the sending data link layer to ask to stop or slow down. So you either ask the sender to stop receiving until you empty your buffer, or your buffer is have some space, or you can ask the data link layer of the sender to slow down the sending frame rate, to slow down the rate of sending frames, so that you can match its speed. Flow control also occurs at the transport layer, not only at data link layer, with a higher degree of importance. When we'll study TCP, it has got this flow control mechanism, which is very sophisticated. We study that when we study the transport layer. So flow control means either the sending you decrease make some communication between the sender and the receiver, so that you can control the rate at which frames are sent. Another service of data link layer is error control. So when you send data from sender to receiver, many times errors, because these are data, so sometimes errors occur in these frames or packets. So we need first to detect if there are errors or not. If there are errors, sometimes, then what you do with these errors, then either correct it. So if you can correct these errors and the packet can be recovered, then it's good. The other thing, maybe sometimes you just discard this frame because you say this frame has got some errors, I cannot correct them, or I don't have enough data to correct them. Just drop this frame. You may ask the sender to resend the same frame again, so until you receive it without errors. So this service is available in data link layer. Error detection and correction is an issue actually not only in data link layer but all other layers. Okay, so it's not only a data link layer issue. Error control is can be done at application layer, at transport layer, at any other layer. Another service is congestion control. Congestion may result in frame losses. So what's congestion? When you have loss of data, traffic coming, so not only competing for the bandwidth. So in this case, you may have frame losses. Most data link layer protocols do not directly use congestion control. Some wide area networks use congestion control at data link layer. Congestion control is actually considered an issue in the network layer and or the transport layer. So we mostly deal with the congestion control at actually the transport layer, but you can do some control even at data link layer. The data link layer is actually subdivided into two sublayers: the data link control sublayer and the media access control sublayer. But if we have a point-to-point, we'll study this in much more detail in the coming lectures, but we will not go into the details of this sublayer. So if data link control deals with all issues common to both point-to-point and broadcast links. So point-to-point means there is no other connection. This is so you don't have in this case media access control, because this is directly connected to this. But when we have broadcast links, something like this, so you need the media access control sublayer so that you can do the node-to-node delivery. Okay, so generally we have two sublayers, but if you have a point-to-point link, you only have the data link control sublayer. We'll mostly study the media access control sublayer, or we call it MAC layer. So MAC is part of the data link layer. It's a sublayer of the data link layer. We'll use some addressing in the data link layer. Actually, we use IP addresses, IP addresses in the network layer. But at data link layer, we use another sort of addresses. In an internetwork, such as the internet, we cannot make a datagram reach its destination using IP only. So you need another addressing for node-to-node delivery. The source and destination IP addresses define the two ends. So if you look at a complex network, so when you send data from this device to this device, IP will only tell you this IP of this device and IP of this device. But how to reach from this device to this device? You have to go through many nodes. This end-to-end delivery is responsibility of IP, but node to node, so as we said, the data link layer is responsible for node to node delivery. So from this node to this node, from which node then you'll go from this to this or from this to this. So we have actually routing protocols, we have different so how to go from here to here, from here to here, how to go until you reach this is the responsibility of the data link layer. So IP only is not enough. So if you give the IP of your IP and the receiver's IP, it will not be enough for your data to arrive to the destination. Therefore, we need another addressing. We call it link layer address, and we refer to it as media access control address, or MAC address, or physical address. So all our devices, all our network devices will have a physical address. You can easily check that if you want on your computer. I'll show you at the end of the lecture how to check that on your devices. So we have physical addresses at data link layer. We call them MAC addresses. They are physical because they are not like IP. IP, you call it a logical address because you can set up your IP, you can change it manually, but these physical addresses are actually stored in memory, so you cannot change them easily. Actually, they are stored in NVRAMs, so they will be fixed for unless you use some tools to so if you look here, I'll give you we'll study ARP in the next lecture, so I'll stop the recording for now. To have some discussions.